Something under this mountain is pushing upward right now, and for a long time, nobody knew why. The strangest part is not that it is a volcano, it is that this volcano was supposed to be finished, ancient, silent, done. For anything that has slept this long, we usually use a simple word: dead. But this mountain did not stay still. The ground began to lift, the earth around it began to sink, and scientists realized they were looking at a place that was not truly asleep at all. What they found beneath it changes the way we think about mountains, volcanoes, and how long the planet keeps its secrets. High in the Bolivian Andes, where the air is thin and the land looks almost too empty to belong to Earth, stands a mountain called Uturuncu. It rises more than 6,000 meters above sea level, which means it climbs so high that breathing there feels like trying to pull air through a straw. Snow can rest on its top. The slopes are dry, cold, and harsh. From a distance, it looks quiet in the most complete way a place can look quiet. No glowing lava, no dramatic smoke columns, no obvious warning, just rock, ice, dust, and time. That silence is one reason the story feels so strange. Uturuncu has not had a known eruption in around 250,000 years. That is far longer than the time humans have lived in cities. It is longer than farming, longer than writing, longer than almost everything we call history. In volcano science, the last 10,000 years often matter a lot because that window covers the period when many volcanoes are considered active in a practical sense. So when a mountain has been quiet far beyond that point, our brains want to place it in the safe pile. Old, spent, empty. Finished. But Earth does not care about our piles. The first sign that something was wrong did not come from a person standing on the mountain. It came from space. Scientists use satellite radar to compare repeated images of the same region over time. Radar is a way of using radio waves to measure surfaces. In simple terms, it lets scientists see tiny changes in the shape of the ground, even when those changes are far too small for human eyes. When they studied Uturuncu, they saw something deeply odd. The center area around the volcano was rising. Around that rising center, a much larger ring of land was sinking. It looked like a giant hat pressed into the earth. Researchers later described this as a sombrero pattern. That is not a poetic phrase. It is a real shape the ground seemed to be making. Lift in the middle. Sag around the edges. A broad, giant bullseye across a region roughly 70 kilometers wide. Imagine setting a dinner plate beneath a blanket and slowly pushing it upward from below while the cloth around it pulls down. That was the rough idea. Only this was not cloth. It was the crust of our planet. And the next question was the one that kept coming back. What exactly is doing the pushing? At first glance, the answer feels obvious. Magma. Magma is melted rock beneath the ground. Volcanoes erupt when magma rises and breaks through. So if a volcano starts moving, people naturally think the mountain is loading itself for an eruption. That is the nightmare picture. A hidden chamber fills, pressure builds, the ground swells, then one day the system breaks open. But Uturuncu refused to behave like a simple story. That is what made it so important. If this were only a case of magma gathering below an old volcano, the lesson would still matter. But the data suggested something more confusing. The volcano was not just one chamber filling like a balloon. The pattern was wider, stranger, and more layered than that. Scientists needed to know whether this mountain was waking up in the dangerous sense, or if something else was happening underground. For people living nearby, that was not an academic question. It was the difference between watching, preparing, and possibly evacuating one day, or understanding that the mountain's motion meant something less immediate but still profound. So teams went closer. They put instruments on and around the volcano. They studied earthquakes. Earthquakes are shaking caused by sudden movement in the ground. Small ones matter to scientists because they act like little flashes of light inside the planet. Every quake sends waves through rock, and those waves travel differently depending on what they pass through. That is how scientists can make an image of the hidden world below, almost like a body scan at a hospital. Over several years, researchers used dozens of seismometer stations. A seismometer is a tool that records ground shaking. These stations detected more than 1,700 earthquakes in the area. Each one was a clue. On top of that, scientists measured gravity changes, checked underground electrical properties, studied rock samples, and combined all of it with satellite observations. Bit by bit, the mountain that looked dead from above began to reveal an active inner life. And then came the twist. The deepest worry was that magma itself was charging upward and preparing to erupt. But the best evidence pointed to something more complicated and, for now, less explosive. The movement appeared to be driven mainly by liquids and gases traveling through a magmatic and hydrothermal system beneath the volcano. Hydrothermal means hot water moving through rock. In plain words, the mountain may be restless, not because a giant plug of fresh magma is about to burst through, but because heated fluids and gases are shifting, rising, collecting, and pressing on the crust from below. That may sound less dramatic than lava. It is not, because it means a mountain can look dead, stay quiet, for an age beyond imagination, and still remain alive inside in ways we barely understand. To see why this matters, we need to go deeper, far below the visible volcano. Utarenchu sits above one of the largest known bodies of magma in Earth's crust, in a vast volcanic region called the Altiplano Puna Volcanic Complex. A complex is just a large connected system. This one is enormous. Deep underground, there's a huge zone where rock is partly molten, partly solid, and loaded with heat. That does not mean there's a giant open cave full of lava sloshing around. Real magma systems are messier than that. Think less of a tank and more of a sponge of hot rock, melt, crystals, gases, and pathways. That mess is what makes volcanoes hard to read. People often imagine volcanoes as simple pipes. Pressure rises, lava climbs, eruption happens. In reality, the inside of a volcano is more like a city of broken tunnels, sealed pockets, hot fluids, old scars, and shifting pressure points. Some routes open, others close. Gas can build in one place, while liquid moves in another. Heat can remain trapped long after eruptions stop. A volcano may look inactive at the surface, while deep underground, matter is still moving through the leftovers of its old plumbing. Utarenchu seems to be one of those places. The newer imaging showed possible upward pathways where heated fluids were traveling toward the surface. It also showed a zone where gas had gathered beneath the crater. A crater is the bowl-like opening at the top of a volcano. The shallow gas accumulation below that area may be enough to help push the center upward. Meanwhile, the broader system around it responds differently, leading to the sinking ring. In other words, the mountain's famous strange shape may not be the sign of one simple magma surge. It may be the surface expression of a living, breathing underground fluid system. That is why some scientists called it a zombie volcano. It is a dramatic nickname, but it fits. A zombie is something we thought was dead that still moves. Utarenchu has not erupted in 250,000 years, yet it releases gases. It experiences earthquakes. Its surface deforms. It is not active in the obvious, movie-like way. But it is not truly gone either. It still has circulation. It still has pressure. It still has motion. And once scientists saw that clearly, one larger and more unsettling question opened up. How many other mountains have we misjudged? This is where the story grows beyond one volcano in Bolivia. For years, many people treated very old volcanoes almost like old machines in a field. Interesting, maybe beautiful, maybe dangerous once, but no longer part of the immediate story. Yet Utarenchu suggests that such places may not be silent at all. They may still be processing heat, gas, fluids, and stress deep below us. They may still be changing very slowly until one day they change in a way we finally notice. And that raises a problem for us. Human beings are bad at waiting for slow danger. If the ground shook hard every week and orange lava ran down the slopes, our attention would lock on instantly. But a mountain that rises by a centimeter a year does not trigger panic. A centimeter is about the width of a fingernail. You would never see it happen. A child could grow more in an afternoon nap than the land below Utarenchu rises in months. Yet year after year, that tiny lift adds up. Quiet change is still change. The Earth is full of slow motions that only become obvious after years, decades, or centuries. That is one reason satellite radar changed everything. Before tools like that, many of these motions were hidden from us. The land could bulge, settle, tilt, or stretch without anyone truly knowing. Now we can compare scenes across years and detect deformations smaller than what your eyes could ever catch from the ground. It is like putting a ruler against the skin of the planet. Once you can do that, old assumptions begin to collapse. And sometimes they collapse in an uncomfortable way. Because one of the safest feelings humans can have is the feeling that we have named something correctly. If we call a volcano extinct, we relax. If we call a fault quiet, we build. If we call a mountain stable, we stop looking. A label can become a sedative. But labels are tools, not truths. Nature does not freeze because we gave it a category. That may be the most important lesson in this whole story. Still, it leaves the big question hanging. If Utarenchu is moving, if fluids and gases are active below it, if the crust is rising in the middle, are we actually watching the early stage of a future eruption? Is the mountain only pretending to be calm? The current answer from the researchers is careful, and that caution matters. Based on the data they gathered, the likelihood of an imminent eruption appears low. Imminent means likely to happen very soon. The system seems active, yes, but not in the simple way that suggests a sudden eruption is right around the corner. That is reassuring. But notice what that reassurance really means. It does not mean nothing is happening. It means scientists now think they understand the kind of happening they are seeing more clearly. That is different from safety in the absolute sense. Volcano science rarely gives absolute comfort. It gives better reading, better warning, better odds. A volcano is not a clock. You do not wind it, do the math, and get an exact date. What you get instead is a picture of the system's behavior, and that picture can change as new data arrives. Today, Utarenchu looks like a restless but not immediately eruptive mountain. Tomorrow, or 10 years from now, new signals could shift that view. That is why monitoring matters. The story is not over because the answer is probably not soon. In a way, that answer makes the mountain even more fascinating. If it were about to erupt tomorrow, the story would become simple. Danger, countdown, blast. But Uturunchu tells a slower, stranger story. It says a mountain can carry old heat for immense spans of time. It says that fluids and gases can move through buried volcanic plumbing long after the main fire seems gone. It says the deep earth is less like an engine that switches off and more like coals buried under ash. The flames may not be visible, but the heat remains, sometimes for far longer than we imagine. That image helps explain why this mountain matters to more than volcanologists. Volcanologists are scientists who study volcanoes. What happens at Uturuncu may also help us understand how valuable minerals form underground. Fluids moving through hot rock can pick up metals and carry them elsewhere. As they cool or react with surrounding rock, they can leave those materials behind. Over long spans, that process helps create mineral deposits. So the same hidden circulation that lifts the volcano may also tell us where copper and other useful resources concentrate. That is a strange turn, but it makes sense. The mountain is not only a hazard to watch, it is also a record of deep processes that shape the world we depend on. And those processes are older than us. Think about what 250,000 years really means. When Uturunchu last erupted, there were no borders, no books, no maps with Bolivia written on them, no satellites, no aircraft, no cities lit at night. Entire human civilizations would rise and vanish long after that eruption was already ancient. Ice ages shifted, species changed. Languages that have not even been imagined yet would eventually be spoken. Through all of that, the mountain stayed there, holding heat and pressure in the dark. That scale can make human life feel tiny, but it can also sharpen our attention. Because even if the deepest story belongs to geologic time, the risks and lessons belong to us now. There's another reason scientists took Uturunchu so seriously. It is not alone. Researchers who study ground deformation from space have found other volcanoes around the world that show strange signs of motion despite long, quiet histories. Not all of them are the same. Some may be recharging with magma. Some may be releasing fluids. Some may simply be adjusting as heat and pressure redistribute underground. But the pattern is clear enough to unsettle the old picture. A mountain does not need fresh smoke and recent lava to remain part of Earth's active machinery. That should change how we watch the planet. For most of human history, we only knew what a mountain was doing if it did something large enough to scare us. A loud explosion, a river of lava, ash falling from the sky, maybe an earthquake so strong that cups rattled in kitchens and walls cracked. But the quiet signs were invisible: the slight rise of land, the slow shift in gravity, the faint change in how electrical currents move through the ground. Those were hidden chapters. Now we can read them. And reading them may one day save lives. That point becomes clearer if you imagine the opposite. Imagine a volcano believed to be long dead. Nobody checks it closely because there seems to be no reason. A century passes, then subtle motion begins. No one notices. Gas pathways open, pressure changes. Small quakes start deep below the surface. By the time obvious signals appear, the system is already far along. Monitoring does not stop eruptions. But it buys time. It turns surprise into warning. Sometimes that difference is everything. So when scientists spent years building a three-dimensional picture of Uturunchu's hidden system, they were doing more than solving a mystery. They were testing a method for understanding quiet danger before it becomes loud danger. Their approach combined many tools because no single tool is enough. Seismic data reveals how waves move through rock. Gravity measurements hint at how mass is arranged below. Electrical methods help show where fluids may be present because wet or altered rock can carry current differently from dry rock. Rock analysis tells scientists what materials are in the system and how they behave under heat and pressure. Satellite radar tracks surface deformation over time. One method alone is like hearing only one instrument in an orchestra. Together, they begin to reveal the whole piece, and what that piece suggested was both calming and haunting. Calming because the mountain does not currently appear likely to erupt soon. Haunting because it means the mountain is still alive inside after silence so long it should have fooled us forever. This is the part of the story where many people would stop and say, fine, so it is active underground, but if it is not going to erupt, why should I care? That is a fair question. The answer is that Uturunchu exposes a wider truth about the earth beneath us. We walk across crust that seems solid and final. Roads are paved, houses are built, maps are drawn. We live as if the ground is the fixed part of reality. Air changes, water flows, weather comes and goes, but the ground feels like the safe layer, the stable layer, the permanent layer. It is not. The crust is more like a skin than a slab. It bends, it cracks. It stores stress. It floats over hotter, slower, deeper systems. Beneath some mountains, fluids travel for ages through microscopic spaces and broken pathways in rock. Beneath others, melt collects in pockets too small or too deep to erupt, yet large enough to deform the surface. We are used to thinking of dramatic geology as rare events, but in truth, dramatic geology is often the surface expression of constant hidden motion. Uturuncu gives that hidden motion a face, or maybe a pulse is a better word, because the volcano seems to pulse upward, not all at once, not in a catastrophic burst, but steadily enough that instruments can track it. Around 1 centimeter per year in the central rising area, that is tiny to a person. It is meaningful to a scientist. If your heartbeat moved a building roof by the width of a fingernail every year, nobody would notice from the street. But if you had sensors on the beams, you would know the structure was not still. And stillness is what we crave. There is something deeply human in wanting ancient places to stay ancient in the passive sense, like a museum display that will never surprise us. A mountain that has been quiet for 250,000 years feels like it has earned the right to be predictable. But Earth is not a museum. It is an unfinished process. A volcano does not become harmless simply because our species arrived late to the story. Halfway through this mystery, that was the hardest mental shift. Scientists first saw the deformation and did not know what it meant. Some suspected magma moving upward in a direct way. Others wondered about broad crustal processes deeper down. The famous sombrero shape looked so unusual that it resisted easy explanation. That uncertainty lasted for years. Imagine having one of the strangest ground deformation patterns ever seen at a long, quiet volcano and not being able to say with confidence what was causing it. That is not just a technical puzzle. It is the kind of open loop that keeps researchers coming back for decades, because the answer changes more than one mountain. If the deformation had turned out to be straightforward magma recharge, then the lesson would be about eruption risk at dormant volcanoes. But the evidence for gases and fluids moving through a huge old volcanic system tells a richer story. It says that volcanic unrest is not one thing. Unrest means signs that a volcano is changing or becoming active. Those signs can come from magma, from gas, from hydrothermal water, from stress changes, or from several of these at once. In other words, a moving volcano is not always a volcano racing toward eruption. Sometimes it is a volcano adjusting, breathing, circulating, and releasing energy without blowing its top. That may sound subtle. It is not subtle for people who live near such places. In volcanic regions, decisions depend on interpretation. Do you issue stronger warnings? Do you change hazard maps? Do you increase monitoring? Do you tell local communities this is a reason for fear or a reason for attention without panic? Bad interpretation can cause two opposite harms. It can trigger false alarm and erode trust, or it can underplay a real risk and cost lives. That is why understanding the exact cause of movement matters so much. And there is another layer here that makes the story even more unsettling. Uturuncu sits in a region shaped by subduction. Subduction is when one tectonic plate sinks beneath another. Tectonic plates are giant slabs of Earth's outer shell that move very slowly over time. Where one plate dives below another, rock melts, pressure builds, and volcanoes often form. So the mountain is part of a larger machine that is not switched off. Even if Uturuncu itself has been quiet at the surface for an immense span, the tectonic forces that built the Andes are still in motion. The conveyor belt beneath the region keeps working. Heat keeps rising. Materials keep changing state. The mountain is old, yes, but the system around it is still alive. That helps explain why dead is such a dangerous word. Dead suggests nothing is feeding the process anymore. No input, no change, no future. But volcanoes can stay connected to deep heat long after they stop erupting. They can keep hydrothermal circulation going. They can keep releasing gas. They can keep deforming. They can remain part of the larger chemical and physical exchange between deep Earth and surface Earth. To call them dead may be less a scientific truth than a shortcut for human convenience. And shortcuts can blind us. This is also why the story has a kind of emotional force that goes beyond geology. We live in a time when many of the systems around us feel mapped, measured, and known. We can zoom into a street from orbit. We can watch storms from space. We can model the climate, scan the ocean floor, and send robots to other planets. It is easy to believe that the hidden parts of Earth are shrinking. But then a mountain like Uturuncu reminds us that below the surface, our own planet still contains large zones of mystery, not on another world. Here, under rock we could stand on. Under silence, we mistook for certainty. And here is the part that lingers with many researchers. If new tools had not existed, we might still think this volcano was simply done. That is worth pausing on. The mountain did not suddenly begin moving the day we noticed it. It had likely been changing before we had the right eyes to catch it. In some readings, the uplift may have begun relatively recently on geologic terms, but still long before public attention found it. That means the event did not wait for us. The Earth kept going. We just arrived late with better instruments. There is humility in that. The planet is not performing for human observation. We are eavesdropping on processes already underway. Once you see the story that way, the title question changes. It is no longer just, why is this ancient mountain moving? It becomes, how many deep systems are active all around us without any obvious sign at the surface? How much of Earth's real motion happens below our threshold of notice? And how often do we confuse silence with emptiness? This is where the volcano becomes personal. Not because most of us live near Uturuncu, we do not, but because most of us live with the same mental habit. We assume that what we cannot see is not changing. We assume quiet means safe, still, known. Yet from volcanoes, to faults, to ice sheets, to groundwater, some of the biggest planetary stories begin as tiny signals almost nobody notices. A few millimeters here, a slight heat change there, 1 year of motion, then another. Long before disaster, there is often drift. Long before collapse, there is often a whisper. Scientists spend their lives learning how to hear whispers. At Uturuncu, that whisper came from radar, earthquakes, gravity, and the slow logic of rocks. Each method alone offered only part of the truth. Together, they revealed a mountain whose core story is not an imminent blast, but a hidden circulation system still active after a staggering span of time. Gas collects, fluids rise, pressure lifts the central ground, the surrounding area subsides. The old plumbing is not empty. The ghost of the volcano still has blood in its veins, and maybe ghost is not even the right image anymore, because ghosts are echoes. Uturuncu is not just an echo, it is a process continuing in the present. Slow does not mean past tense. Deep does not mean over. The mountain is not merely remembering its violent history. It is still participating in it, 1 centimeter, 1 quake, 1 gas pulse at a time. This is also why scientists keep watching. Not because they expect a sudden apocalypse tomorrow, but because a system like this is a laboratory written into the crust. Every measurement teaches them more about how volcanoes age, how hydrothermal fluids behave, how gases shape pressure underground, and how the surface records hidden change. And what they learn here can help interpret other volcanoes that begin to stir in the future. One mountain's puzzle can become many mountains' warning system. That may be the quiet triumph in all of this. We did not just uncover a mystery, we improved our ability to read the planet before it shouts. But the story would feel incomplete if we ended with only that practical lesson. Because there is still the emotional core that pulled us in from the start. A mountain thought dead moved. It moved after a silence so long that whole worlds rose and vanished beneath the sky while it stood there. It moved not with a roar, but with a patient pressure from below. That matters because it forces us to admit something most of us resist. The oldest things are not always finished. The stillest things are not always still. And the earth beneath our feet is less settled than it lets us believe. Look again at the image of that lonely peak in Bolivia. Thin air, high desert, snow on dark rock, no crowds, no warning sirens in the picture, no fire at the summit. If you were dropped there without context, you might think you were standing beside one of the quietest places on Earth. In one sense, you would be right. In another, you would be standing above a deep, active conversation between heat, fluid, gas, pressure, and stone. You would be standing on a place that has been whispering upward through the crust while we slowly learned how to listen. And maybe that is the deepest answer to the mystery. The mountain is moving because silence is not the same thing as death. Not in geology, not on this planet, maybe not anywhere in nature. Uturuncu did not break the rules of Earth. It exposed the rules we had simplified. Volcanoes do not always wake with lava first. Ancient systems do not always cool into emptiness. Time does not always erase danger or motion or meaning. Sometimes it only buries them deeper where they wait until new tools, patient science, and a little human stubbornness finally bring them back into view. So no, this is not the story of a monster mountain about to explode without warning. It is stranger than that. It is the story of a volcano that stayed alive in the dark long after common sense said it should be gone. It is the story of scientists finding a heartbeat where the world expected stone. It is the story of how a rise too small to see from the ground opened a window into one of the hidden systems of our planet. And if that feels unsettling, maybe it should. Because the lesson is not only about one peak in the Andes. It is about the world we live on, a world that can look ancient, calm, and complete while deep below, immense forces are still rearranging the future. A world where the most important changes do not always begin with noise. A world where a mountain can keep one secret for 250,000 years and then reveal it by moving just enough for us to notice. That is the kind of fact that stays with you. Not because it is loud, because it is true. And once you understand that, every quiet mountain looks a little different.